especially to you, Miss Dizon. I am Christine Dayan Amarante, together with my group mates JV Avila and Jean Carriaga, are here to discuss the given three topics, of course, from you, ma'am, for our oral performance. So, without further ado, let me start discussing the first one. So, scientific method is the method of research. It provides objective, standardized approach during the conduct of experiment, helping to improve the outcome, which is the fact information. In a sense, that standard approach is based or use investigation before making conclusion to avoid personal assumption. And in this method, questions are being answered either disproven or proven after the test. On the other hand, scientific method have 6 steps based on the course pack. So the first one is observation. In this step, writing down what you're noticing on a certain things that you want to know is essential. Let's say that I noticed lots of people drinking alkaline water because they think it's healthier for them, but I'm still not sure if it actually is or not. This is where the second step come up, which is the research. So, through curiosity, I want to know if alkaline water is actually healthy for us. So that's why I need to research online for articles or publish scientific papers showing how people change when they drink alkaline water. So the next step is hypothesis. This is where researchers write what they think is going on and what theory might explain the observation. For example, after doing background research, it showed that there wasn't much of an effect on overall health. So the hypothesis or the theory for this might be drinking alkaline water has no effect on individual's health. So the next one is experiment. As for you to have a concrete answer, we need to gather more data and conduct an experiment, just like we need individuals or a person to drink the normal and alkaline water to know the different effects of this kind of water. And after that, we need to ask them and to rank how well they feel after drinking each. So next thing we have is the analyze. So in this step, we need to review the data from experiment to have logical conclusion. For example, now that you've already done collecting your data from alkaline water experiment, and we could say that there is no real difference on how people feel based on what type of water they drink. So maybe, or this could be the answer or the result after the experiment. So in this case, we accept the original hypothesis, which is the alkaline water will just be a scam, or it simply means that it didn't really affect how will people feel after drinking this product. So obviously we have now the result, and finally we can decide if the hypothesis is correct or not. So in this case, the result would be alkaline water is just a normal water that haven't any effect, or it didn't affect how people feel or can affect individuals' overall health.
In 2017, in the book of Mosset, he enumerated the fundamental tenets of scientific method, which has already begun in 1400s. Here are the following fundamental tenets enumerated in scientific method. Source of information, phenomena that can be studied, constancy and universality. The last one is basis. Source of information. This means that all recognized facts can be derived only from careful documentation and controlled experiments. In other words, any claims which comes from priests or prophets or even scientists can't be accepted automatically unless it is verified through accurate testing or produced proofs. For example, today in our modern time, many various drugs, herbal supplements are advertised curing illness or improving health. Under the scientific method, such claim themselves even if made by famous and respected drug companies are not sufficient. The actual data must be available and the research must be described so carefully that other or independent scientists can repeat the study so as to determine whether the drugs or supplement are indeed effective or whether these are cases of false advertising. Phenomena that can be studied. This entail that only tangible, sometimes that can be touched. Phenomena and objective are studied, particularly heat, plant, minerals, even weather. It is a fact that magnetism or neutrons cannot be seen or felt, but instruments are invented to be able to detect them reliably. In simple words, whatsoever that cannot be observed cannot be studied. Examples of it are microorganisms, include bacteria, protozoa, and etc. They cannot be seen or felt, but there are instruments are invented to be able to detect them and see them, like microscope. It is a tool used to see small things that I couldn't. Constancy and universality. A physical force that governs the universe are constant through time and in any place. To elaborate, experiments that are done at one time and place should give the same result even if it's repeated at a different time and place. These tenets allows us to design future experimentation and to make prediction of what the outcome should be. If the experiment does not get to the prediction outcome, it must be concluded to our theory was incorrect. Not that the necessary force of the world have unexpectedly changed. And for the last basis, the cardinal basis of scientific method is skepticism. To simplify put this, skepticism means doubt. This is the basis of never being assured of what conclusion. It also means to always be prepared to examine new evidence. For example, there is tremendous amount of evidence supporting the theory of all plants are composed of cells, and there is no known evidence against it. All research and all our teaching assumes that plants are composed of cells, but the concept of skepticism requires that if new, contrary evidence is presented, we must willing to change our minds. As further example, consider people have been convicted of crimes, then later on or often years later, DNA-based evidence are indicated that they are innocent. Skepticism is the willingness to consider new evidence.
Scientific theory attempts to explain the laws in terms of something more basics. In popular use, a theory is often consumed to imply mere speculation. But in science, something is not called a theory until it has been confirmed over many independent experience. Theory are more certain than hypotheses, but less certain than laws. The procedures are process for testing. Theory are defined within each scientific defined. Example, between 2017 and 2020, Joven cultivated and tested some 28,000 pea plants, which brought forth two theories of how character traits are inherited aeronically. When Joven paper was published on January 21, 2022, it had little impact. It was the early century that the enormity of his ideas was realized. A scientific law, it is an experimentally determined behavior of nature that is quantitative and reproducible. Chemistry full of them, such as the ideal gas law, Rolle's law of partial law, Henry's law of gas solubility, and liquid, and so on. Many of these laws hold under the ideal conditions, such as low pressure, for the ideal gas law. So correction terms are added when it needed. Scientific law and a scientific theory. So when can you see that the statement is talking about a scientific law or a theory? Well, if it is explaining what, you're talking about a scientific law. But then, if it is explaining why and how, you're talking about a scientific theory. Since a scientific law is an observable behavior, you cannot argue whether it is true or not. Although, you can show that it holds under a certain condition only. And since the scientific theory is an explanation, it was always subject to debate. A different theory may work better or the theory may have to modified. However, new technology often proves a theory to be correct.